The average atomic mass of carbon from its two main isotopes, carbon-12 and carbon-13, is 12.011 AMU. What is the percent of each in a sample of carbon? So this question is giving you the average here. It's telling you when you put those two isotopes together in a sample, the average is pretty close to 12.011. But the question is asking how much of your sample, what percent of your sample is carbon-12, and what percent of your sample is carbon-13. Note that I know I'm talking about carbon-12 and 13 by the number in the superscript there. So we're dealing with carbon-12 and carbon-13, and the question is, what is the percent of each if the average atomic mass is 12.011 AMU? The fact that the average atomic mass is 12.011 AMU, very close to 12, should imply that we should get a very large percentage of this being carbon-12 and a very small percentage of it being carbon-13. So that's something to look out for when you get your final answer to see if you are right or not. Now, this is the trickiest part of these questions, is deciding, well, how do you figure out then what to put in for the unknowns? Oftentimes in math, when we don't know something, we call it X. And sure, that'll work fine there. But we can't put an X in for carbon-13 as well, because that would imply, when we do the mathematics, that X is the same, and we should get 50-50%, which is not the case for this. Clearly, it's closer to carbon-12 due to what the average that's given to us, what that works out to be, very close to 12. So we know we'll call X 12, but what you got to do here when you have two of these things is remember that percents are out of 100. That's what percent means. So if you have X percent of one thing, you have to have the remaining has to add up to 100. So imagine that you made 80% on your test. That means you got 80% of it right, but it implies then you have 20% wrong. You can't possibly get 80% on a test and then get 60% of the questions wrong. That's not the way the percents work. So if we're going to call one of our unknowns X, and it actually doesn't matter which one you call X, but we'll call carbon-12 X since it's on top, the other one has to be 100 minus X. So that should make sense that if X works out to be 95, let's say, then carbon-13 would have to be 5%. You can't have over 100% of something. So that's the little trick there, is it's 100 minus X. There's harder ones than this too, so do your homework, but for now we'll stick with this one. So we have our percents lined up, and again, that's one of the harder pieces. So let's put the numbers into the formula. So we know that average atomic mass is equal to the sum of the percent divided by 100 times the mass number. And we have both mass numbers, 12 and 13 here. So let's put in the numbers in this equation. AAM, we know it's 12.011. Notice I'm not putting in my units because it becomes tedious when you're going through the whole example. You probably should. It's good practice. However, I'm concerned with your units at the end. So the first one is X. We don't know what that is, over 100 times 12. And again, the sigma means add up. 100 minus X is the percent there. We don't know what that is yet. Divided by 100 times 13. The next step then is to do a little bit of factoring here that we need to multiply through in this case. And so we take 12 times X, and we get 12.011 equals 12X over 100, plus, and this is where it gets a little bit tricky, so remember your math, that this whole thing is on top here, and the 13 is going to be multiplied by both the 100 and the X. So we get 1300 minus 13X all over 100. So this is starting to come together now. Remember this little trick from your old math classes. When you add fractions together, it's important, it's in fact necessary, that the denominator be the same. Do you remember common denominator? In this case, and in all these questions, because it's always divided by 100, you'll always have a common denominator. So you can add these two fractions together and get one longer algebraic expression out. So I'll just do that here. It'll be 12x plus 1300 minus 13x, all divided by 100. So now we have basically 12.011 equals an algebraic expression over 100. How do you get rid of the 100 on the bottom? Well, if the 100 is dividing into the 12x plus 1300 minus 13x, to get rid of it, we need to multiply by 100. So note there's 100 on the top, 100 on the bottom. That means they cancel. Anything over itself is just 1. So 1 times 12x plus 1300 minus 13x is just 12x plus 1300 minus 13x. So we're left with that by itself. But what you do to one side, you must do to the other. And I'll skip the middle step here since we're really only concerned with this over here, not to multiply that by 100. So I would get 1201.1 equals 12x plus 1300 minus 13x. So now we have a nice algebraic expression for x, and we're getting pretty close here. The next step in algebra is to combine like terms. And so because we have an x here and an x here, we can combine these things. Don't forget the minus here as well. So 12x minus 13x is going to give us just minus x. And so the next step looks like this. Again, 12x minus 13x is negative 1x, which is what we have here. So we're getting close. We want x by itself, which is really what we were trying to get at all along to get that unknown. So we just got to move the 1300 over, and we will have a final answer for x. So since I have a positive 1300 here, I want to get rid of it by subtracting off 1300 on this side. Since 1300 minus 1300 is 0, it's simply gone. You can think of it that way. But again, what you do to one side, you must do to the other. So I'll subtract off 1300 on this side. And what I'm left with then is negative 99.89 equals minus x. The negative then can be switched around. Sorry, 98.89. What I'm left with here is negatives. And if you really think about this, you can divide out negative 1 on both sides, and it simply switches them to being positive. So now we know x percent up here is 98.89%. And if we put in 98.89 into this equation here, we get 100 minus 98.89 is 1.11%. And so our final answer then is the percent that this sample would be carbon-12 is 98.89%, and the percent that this sample is carbon-13 is 1.11%. And that makes sense. Again, we assumed from the very beginning that we should have a lot more carbon-12 than carbon-13 from our original average atomic mass.